So welcome to our walkthrough. As you can see, it is the summer 2019 for Edexcel Higher and it's paper one, so keep those calcs hidden. Number one kicks off with some basic probability, and as you know, probabilities must add up to 1. So these two must add up to 0.8, and you're told it's the same. In it goes a couple of 0.4s. Then you're told there are 12 blue cubes in the box. So the probability of a blue is 0.2. In other words, a fifth, and that makes 12 cubes. Well, we want the probability to be 1. We want the probability to be all probabilities. And all probabilities add up to 1. Well, that would need 5 times as many. Do the same to your 12 for a nice 4-mark starter. Number 2, not a fan of this question. It's just over the top, isn't it? Just wordy for the sake of words. Who cares? So 50 grams of sugar for 15 biscuits. So 3 times as much flour. So let's just one thing at a time with all these over the top wordies. So flour would be 3 times as much, 150 grams. 2 times as much for B, for butter, 100 grams. To make 60 biscuits, that would be a multiplier of 4. You need 4 times the ingredients. So how much flour? 150 multiplied by 4. Well, 15 fours are 60. Stick a nought on for 600 grams. Then we've got to buying all the butter to make 60 biscuits. So we've already started the work here. There's part of our working out for B. Well, 4 times as much means we need 400 grams. So 1 pack's not enough. 2 would give us 500. 2 would cover the amount required. Number 3, if you want to make a list, because they're not the biggest numbers, feel free. But for revision, I would always recommend going for the factor trees, and if you do Venn diagrams or just multiply common factors, it's your choice. So 72, let's split it differently. 4 18s, 2's prime, 2's prime, and don't be afraid of 3-way splits. 3 times 3 is 9 times 2. Speeds the process up. With 90, again, let's go for a non-standard split. Not a lot of people go for 6 15s. 2 3s are prime. 5 3s are prime. Like I say, they've given you room for the Venn diagram down here. That's no coincidence, but I don't bother with that. I just go, yep, there's a 2 in each. Yep, there's a 3 in each. There's another 3 in each. And there's no others in common. Get them multiplied for the HCF of 18. And if you wanted the LCM, you do 18 times all the ones which haven't been included so far. Number 4, so from above, it's a circle. From the front and the side, it looks like a box. That's because it's the old kitchen roll. It's the toilet roll, whatever the heck you want to call it. It's a cylinder. Your artistic talent does not matter. It's about the right basic shape. Don't draw that line down here. I know some people are tempted. But it says give the dimensions. That's where the marks are coming from. So it wants to see that on the plan, you can see that the diameter is 4 centimeters, or in other words, the radius is 2. It's your choice for which one of those you want to label, diameter or radius. Labeling one means you've accounted for both. And if you count the height, it's 5 squares. And don't forget it's centimeters squared paper. Number 15. I've already had a start of this because it's a waste of time watching me reflect something in the x-axis. That's too easy. So there we go. That's the reflection of A. And then it's translated. So pick a vertex and the corresponding vertex and get counting. You'll see it's left 6, down 1, left 6 in a vertical in C and D like that. Left 6 is in vector form is -6 and down 1 is -1. Number 6, our old friend over the top waffly ratio. So, too many words, simplify it. It says on the top line, we've got B pens, R pens, and G pens. In terms of packs, it's 7 to 3 to 4. But for black pens, there are 2 in each pack. So actually 7 packs means 14 pens. There are 5 in each pack of red. That means 15 pens. There are 6 in each pack of green. So that means 24 pens. So if we were doing a standard ratio question, we'd add them up. We get the horrible number 53. We'd like to have a calculator that do spot. 53 does go into 212. If you double 53, you get 106. Double it again. Yep, 212. It goes in 4 times. They've made it quite nice. So, work out the number of green pens sold. Well, the fraction of green pens sold is 24 over 53 of the 212, and of means times. Doesn't look very friendly without a calc, but don't forget what I've said. 53 goes into 212 4 times. And your top times top gives you the lovely easy answer of 96. Question 7. Hidden algebra. QR is 10. Get it on your diagram. BC, whatever the heck that is, it's equal to PQ. So we've dealt with these lines. The perimeter of ABCD is 26. That's going all the way around. The area of PQRS is 45. There's our starting point. We've got a link. Area divided by length will give you width. That's 4.5. Take that across. That means these are 4.5 as well. So, AB, don't know how big it is. Let's call it a different letter. So the perimeter of the first rectangle, add all the sides up, 2y and 9 gives us that 26. So if you take away 9 from both sides, you get 17. Half of 17, 8.5. Job's a good one. Number 8. So the spot here is, yes, 63.5. Tempting to round off to 60. But don't forget, 64 is a square number. So I would go for 64 lots of 100. Or in other words, 6,400. Square root of 64 is 8. Square root of this is 80. If you've gone for 600, sorry, for 60 there, and you've got 6,000, as you can see, a little bit more difficult to estimate. Mark scheme does allow a lot of leeway, 75 to 81. So you are allowed a little bit of guesswork, but that 64 is the spot there. Next one, 2.3 to all that power. Well, at the end of the day, It's the number of digits after the decimal point that's important. So if we know that 2.3 is 148, that's smaller. So the 148 is going to appear on the right-hand side of the number. It's going to be 0 point, and so on, and so on. So find the value of 0.23 to the power of 6 to 3 significant figures. So you're going to be needing 6 digits after the decimal point for the right answer. Okay, so on we go. Find the value of 5 to the minus 3. Don't forget minus power means 1 over. And 5 squared. Nice. You can give the decimal of 0.04, but why bother? So number 9, we've got fractions. You know it's coming up. They're going to give you one of the 4 operations. They're usually going to use mixed fractions, so you've got to be prepared for these. You know they're coming. So we'll make both improper, top heavy, whatever you want to call it. 3 times 2 is 6, plus the top gives me 7. Big times bottom is 1 times 5, add the top gives me 8. Top times top, bottom times bottom, or you could pre-cancel with the 8 and the 2. It's entirely up to you. 100 times does 10, go into 56. 5 with a remainder of 6, and that remainder has the same denominator. Simplest form though, 5 3/5 for the right answer. Number 10's easy. I've already put a circle on. That's why it's only 2 marks, folks. It does say estimate, so I get 2.25 for there, and I get minus 1.3 for there. And the mark scheme says 2.2 to 2.3 for X, and minus 1.3 to minus 1.4 for Y. Nice and easy. Number 11. So they've given you 23 people not by accident, because you should know about the sigma f plus 1. So of 23 people, it's the add 1, 24. So it's the 12th person that is the median. So the median is 59. The quartile, you add 1 to get 24. You quarter it to get the 6th person. That's 53. And the third quartile, in other words, the upper quartile, treble it, you get the 18th person. They've ordered it, so that's why it's nice and easy to find. And there are your values that were missing in the table. Now, as always with these wordy ones, it's 1 mark. You don't need to fill all 3 lines. Richard says Coach A younger than B. Is he correct? Yes. I mean, you could argue all the datas are smaller, greatest age 79. All the data is basically younger or smaller numbers. But because you want to go for the maths, just say yes. Compare the medians. So just say yes, the median is lower on A. It's 59 compared to 70. And similar things for your range up here. Richard says it varies, so either compare the range or the interquartile range. Is Richard correct? That's a no. And the reason is because the range on A is 38. It's smaller than the range on B. So there is a wider or a bigger spread on Coach B. Number 12, one of them darn questions where they don't feel like they give you enough numbers. My advice, make one up. You could call it 1, you could call it 100. It's entirely your choice, but pick nice numbers. So if I'm going to say that the smallest volume is 1, So if you want to increase it by 50%, you are timesing it by 1.5. But because it wants fractions, I'm going to work in fractions. So 1 multiplied by 3 over 2 is 3 over 2. And 3 over 2 multiplied by 3 over 2 again is 9 over 4. Now that's not the answer, but we're damn close. It says find the volume of sphere P as a fraction of sphere R. Of means times or out of, so it's sphere P out of. Or in other words, you need to take the reciprocal of 9 over 4. It's 4/9 the size. Strange question, that. Number 13, though, reasonably standard. You got loads of ways of going about this. You could go through even right from the beginning. Me personally, I would take this, take an n out, and make the argument that these two numbers are consecutive. One must be odd, and one must be even. It's not possible to have two of the same. Certainly not possible to have two odds. And an odd times an even always gives an even number. So don't write too much for that. They've given you way too much space, but a bit of algebra and a little bit of logic and you're home and dry. Number 14, good old non-calc trig values. So sine 30 is the one everyone knows, that's a half, so these are not the easy ones. You've got to learn them, folks. Learn that little table. I'm sure your teachers nagged you. Tan of 30, there's two ways of writing it. The easiest being root 3 over 3. And sine 60 is root 3 over 2. And as long as you know that, you can see this question isn't so bad. Top times top, it's root 9, or in other words 3. Bottom times bottom is 6. Simplest form. Looks easy, but only if you know those equivalents. Number 15. Whenever I see a question like this, first thing I look for is straight away the radius, because the radius is required for the cone and the sphere, or the hemisphere in this case. So you can just jump straight in. There's no hidden information. You've got all the information that you want. The total, they're just phrasing it in a bit of a daft way. They might as well just say find the volume. The volume is, let's do the cone to begin with, a third multiplied by pi times r squared, well 3 squared is 9, times by the height of the cone, that's 10. And then we've got the volume of the sphere, but because the sphere is 4/3, we'll have it as 2/3, half a size, multiplied by pi, multiplied by the radius, in other words 3 cubed, 27. You can basically ignore the pi, just tidy it up. Non-calc, the numbers have worked out nice. You've got a third times 9, that's 3, times 10. Here, 27 divided by the 3 gives you 9, but doubled because of the top gives you 18. Turns out quite a nice question, this. You add them together, you get 48 pi, so K is 48. Number 16, I hate these questions, not because they're too hard, because I just think they're a waste of everyone's time. So there's 3 digits. It can be 5 on the first. You can have a repeat, so it doesn't go down. It could be 5 different numbers on the second dial and 5 on the third. What a waste of our time. To be different digits, it's 543. But again, it's wasting my time. I mean, at the end of the day, it's 4 really easy marks. They should be question 2 for me. Get on my nerves coming in at question 16. But if you wanted it harder, they've given you one weirder. Not actually bad, these ratio questions, once you know the method. The fact is, just write them as fractions. If they're telling you that these ratios are equivalent, we can state that left over right is equivalent or equal to left over right. And let's just times through both sides. Let's double both sides to get rid of that. Let's times both sides by 3x plus 5. 1 times 3x plus 5 is nice. Obviously, it's a quadratic. We want it equal to 0. You could formula it, but it's non-calc, so it'll factorise. And also, you could do the AC method, but because there's prime numbers all around, I would stick with a bit of trial and error in my head. It's got to be a minus 5 there, because minus 5 times x is minus 5x. And when you get the plus 1 here, that gives you plus 2x. Bosh, you've got it. So find the possible values of x. Change the sign, -1. Change the sign, divide by 2. 5 over 2. Question 18 kicks off with a surge. I'm sure you'll have simplified before if you've been revising. It's root 12. Root 12, the highest square number that goes into root 12 is root 4. So it simplifies to 2 root 3. And you've got to add it to 1 root 3. You get 3 root 3. B's a bit weird. Here's how I think about it. On the top, 1 to the power of 7, who cares? On the bottom, something to the power of 7 is like having something to the power of 6 times that thing to the power of 1. Why have I done that? Well, don't forget, here, you've got a power to a power. Okay? You've got 3 to the half to the 6. And when you've got a power to a power, you multiply those powers. Like so. You'll notice the way they want it, they don't want a third on the bottom, so you have to rationalise. On the top, you get a root 3. On the bottom, you have root 3 times root 3, which is 3, but you've got to multiply by the 27. And there you go for the right answer. Number 19, extremely standard, completing the square again. You know it's coming up somewhere. Get it practiced. Been lucky on this one. It's a nice, friendly, no number, no coefficient of x squared. So halve the number next to x, square it, and take it away. And don't forget the plus 1 you've done nothing with, and tidy up the end bit. In other words, simplify. Don't have to do it here. It's just good practice. So A, don't forget, for the bit inside the brackets, you change the sign. For the bit outside the brackets, oh, sorry, my mistake, look at that. It's got a minus in it, so just wants the A. So just leave it as 3. And it's got a minus B there, so just leave it as the 8. Nearly jumped into a bit of a trap there. Hence, write down the coordinates of the turning point. This is the bit I was on about. In the brackets, in that bit there, you change the sign for the turning point, also known as the vertex. And on the bit outside the brackets, that stays the same. We got there in the end. Number 20. Proportion, but connected proportions. Deal with them separately, then bring them together. H is inversely proportional to P. P is directly proportional to the root of T. Carry on. Given that H is 10, get it replaced. And T is 144, get it replaced. When P is 6, stick it in to both equations. Let's work on the left. So times both sides by 6, K is 60. So our formula is 60 over P. And over here, the root 144 means 12. So C will be 6 over 12. In other words, a half. So the formula is P equals a half root T. Then that final sentence, find a formula for H in terms of T. It wants us to have H equals. So we start with this, 60 over whatever P is. Well, that's P. Don't know why the heck I've written a 2 in there. Did you spot it? Got to be a T in there, you dafty. So it's a half root T, and 60 divided by a half is 120. The root T, I'm having a nightmare with my root T's. Let's make this a good one. That's better. Apologies. Brain went awry. Hopefully not for this one. So inverse functions. So depending on your teacher, there's a couple of different ways of going about this. I always went with the let y equals and rearrange to make x the subject. This is an easy one. I'll do it all in one step. Add 1 to both sides, divide by 3. And for your inverse function, flip the x's and y's, just interchange them. So it should be x plus 1 over 3. As you can tell, B is a bit of a doozy. Loads of room for it. Flip it, wrong button. Bear with, gremlins in the works. So, deal with one bit at a time. This bit means the f of g of x. In other words, stick the formula for g of x into the f of x. So the f of x has 3x minus 1. Replace the x with x squared plus 4 equals 2 lots of, so let's just ignore the 2 for now, g of f. Other way round, stick the f of x into the g of x. So the g of x wants you to square something and add 4. That something was an x. It's now the function f, which is 3x minus 1. Yeah. Let's crack on, because it is 5 marks. There's bound to be plenty of algebra. So, left-hand side, expand and simplify. 3 times 4 is 12. Take away the 1. We get 11. Bit more work over here. Let's leave the 2 out of it. So squaring some brackets, square the first. When I square the last, which is positive 1, I'm going to add the 4 to it. Times the 2 together is negative 3x, and double it. Right, let's get this 2 out of the way. Let's expand the right-hand side. 18x squared minus 12x plus 10. There we go. We subtract 3x squared from both sides. Oh, look what's happening. We leave the minus 12x because there's no more to simplify. And we subtract 11 from both sides. Job is a good one. Heck of a question, but it's obviously compound functions, double compound functions. And another great question. I say great, you probably disagree. Here's how I go about it. There are only red and green counters in a bag. Counter is taken at random, that's you. The probability of a green is 3/7. So let's stop for a sec. How would you work out the probability of a green? Well, the probability of a green is number of greens divided by number of counters is 3/7. So as you can see, you've got an equation. Problem, it's an equation with 2 unknowns. Good news, there's more info to come. So the counter's put back, we reset, 2 more red are popped in, R plus 2. 3 more green are put in, green plus 3. Now, probability of a green is 6/13. Same process. How many greens are there? G plus 3. How many counters in total are there? R plus G plus 5 is 6/13. So, as you can see, people, simultaneous equations, lovely. Let's tidy them all up, let's level them off. Left-hand side, multiply both sides by R plus G, and multiply both sides by 7. Let's tidy it up, subtract 3G from both sides. I get 4G equals 3R. And for reasons I'll come back to, because I've already done this paper. I always do the papers once before I go through these, by the way. I'm going to double these. 8G equals 6R. And as I say, you'll see why shortly. Move on to the right-hand side. Let's times both sides by 13. 13G plus 39. Let's multiply both sides by R plus G plus 5. So we get 6R, 6G, and 30. But we can tidy this up. If we subtract 6Gs from both sides, subtract 30 from both sides, as you can see, that's what I knew was coming. Obviously, if you were doing this question, I'd hope you got to this stage and then you'd spot a connection. And it's up to you. There's other ways of doing it. But for me, I know that 6R is this, 6R is this. So I should be able to set them equal to each other. 7G plus 9 equals 8G. And if we take away 7G from both sides, G equals 9. 9 equals G. That's the number of green counters. And find another equation. Let's go back to this one, really. If there's 9 green, 9 eighths are 72. And that's 6 red. Divide both sides by 6. There are 12 red in the bag. What a question. But yeah, it was simultaneous equations, but not the kind you're expecting. It was hidden and it was tricky probability. What a couple of questions to finish off that paper. Anyway, I really hoped it helped. I'll see you on paper 2, maybe.